Hello everyone, welcome to our Ecdis promotional video. This video is taken by the 4th year students of the Maritime Faculty of Dokuz University in order to introduce the Transas Ecdis in a basic and simple way. Let's get started with our introduction. On the general screen of Ecdis, we see information such as route and speed at the top. For the sections on the side, we can say that there are information and menus that we will frequently use and consider. At the bottom, there are the main menus with the task list and where we can set everything we want to do and see on Ecdis. If we start our explanation from the top right, this overlay button is the one that allows us to see the radar echoes on the Ecdis screen while on voyage. We usually use this setting to determine position accuracy. When we open the overlay, the radar echoes and an image we see on the Ecdis screen should overlap exactly. The AIS button on its side is with a similar function. It is the button that allows the AIS data or AIS targets to be reflected on the screen. The Ahead button is a button that brings our ship to the screen. When we examine the map by sweeping screen and our ship exits the display screen, we can see our ship again thanks to this button. This is the section where we can set the map view as north up, head up and course up. Likewise, the true motion and relative motion selection at the bottom of this. When we take true motion, we see our own ship moving on the screen. The map remains stationary and our ship advances unit by unit. After a certain distance, Ecdis automatically synchronizes the image with the ship again and so on. In relative motion, the image of our ship stops at a fixed point. We can say that everything on the map moves according to us. These are the zoom in, zoom out buttons. We can also use our mouse to scroll to do same thing. This is other one is the information button. When we click that by getting our mouse over an item we want to get information about, we can get the characteristic of that item and other informations about that. For the boundaries, for the lights, we can do the same thing to get information about the lights. The menu that allows us to measure the distance between 2 points as rump line and great circle. As you can see, this is the thumb line measuring thing, and also we can use the great circle distance by using GC button. The other menus are not that important. These are the dark, daylight and night modes for Ecdis. For the bottom menu, first thing we're gonna do is opening menus by task list, screen like this, and now we are able to reach all of the menus of Transas Ecdis. The main panel is the screen we see by default. For the dual menu, we can see our ship steadily on the right side of the dual screen. We see two screens on the dual menu. On the other hand, it is the screen where we can navigate on the map using the left screen. We can use this dual screen, depends on the situation. In the AIS menu, we can also perform the updates that we can make on the AIS device by using this screen. First, we click on the edit button, then we can do what we want to do. We can change the destination navigation status. We can set our ETA from here, other than the AIS device itself. In the messaging section, while we need to write a message using the buttons on AIS, we can do the same operation via Ecdis in a simpler way by using the keyboard. At the same time, these two menus are the sections where we can control and follow every message that comes to us via AIS. The other section is charts. In the chart section, our first section is the panel where we can see our maps and adding, removing them. The layers and ENC screens on the right are very important. It is the part where we can set everything we want to see or not to see on the map from the layer screen. Of course, there is a limit to the amount of information we can remove. For example, coasts and shallow areas, etc. The reason for this is to show to the person the dangers even in the most incorrect use. Here are the default choices that the Ecdis presented to us. Using the custom tab, we can also adjust our display screen according to our personal preference. You can choose them one by one, what you want to see, what you don't want to see. It would be logical to use the All tab while voyage planning, because seeing everything in the place we want to go or pass through in the voyage planning allows us to plan a more effective and less dangerous voyage. However, it won't be a very efficient choice of use, as it will cause visual pollution in the voyage. ENC is the electronic navigational chart. The maps we use on Ecdis are called ENC charts, which means are maps to be used for navigation purposes that comply with certain standards. We can make changes on the views in the areas and point section. Do they look like paper maps? Changing boundary images, etc. For shades, two shade settings, the part we need to open for catswalk viewing. Catswalk, in short, are the symbols that show the accuracy of depth measurements in that region. We can call it quality of depth survey. We can explain it like that shortly. We can change shallow contour and safety contour here, but we can see that from that menu. Other menu is the config menu. In general, we can change the dusk, daylight, night. This is for the display and depends on the time. Also, we can change the skin of the Ecdis menus. Personally, I like metallic. Others are the timer alarms, other settings there. Radar settings we can change. Time zone, we can set time zones, ship's time and default UTC time we can see there. These are the license information about the Ecdis. CompTrace, not that important. We can set our units by using this. Kilometers, hours, knots, nautical miles, kilometers for the distances. These are the units. Ship settings set by service. These are the basic settings that cannot be changed by personnel. This diagram shows us the antenna position, and here we can see the distances between antenna to foresight, offside, starboard and port side. This is the road settings. We can change safety contour, safety depth, and turn radius by this menu. CCRP position.
In this section, we'll talk about the logbook. Logbook section, we are first selected and activated from here, the logbook. After that, we are selecting the logbook here. The logbook section shows historical voyage information about the ship positions, events, alarms, speed over ground, course over ground. About all historical information can be found in this section. After that, to see the information on the date, we are selected from here of the date, and we enter the date from this section. After that, show us to here of historical events according to date. Another section is manual correction. First, we are selecting in this manual correction and we are activating from here. In manual correction, we firstly I will show off the adding of the object. From here we can add of the objects like symbols, line, text, depth, and shapes. I will show adding object. I'm selecting like a symbol, selecting of the boy and clicking of the add object. I'm adding object to here. After that we can edit of the object. Editing of the object and shifting, we can delete of the edit object. If I wanted to shift the object, I'm clicking from here shifting and click of the object. I'm selecting of the shifting point to here. The object is shifted. I can delete of the object. I'm selecting of the delete object. Again click to the object and the object is deleted. If we wanted to see of the deleted object, that this deleted button should be selected. If I click again to the deleted, I didn't see of the deleted object. On the other hand, we can restore of the object and attach a label to the object. I'm selecting of the attach, click again to edit object, and I can attach the anyone to here. And here giving of the symbol information, edit and change any information, starting time and stop time. Another section is map sections. We use this part to arrange and bit of the maps. We can add position, fix interval, shapes, PI in the section. Firstly, we should load of the maps to here. After that, we can add again of the objects and edit. First, I will show create a new map. New map is created. From this section, a new map arrangement file is opened and named from the site tab. For example, we add and delete new object on this newly saved map. I will show. I'm clicking a object and adding object. Yes. Here, edit new object. And during the voyage, we can delete any correction that are not related to the higher voyage. For this one, we are editing of the object. We select of the delete button. I'm clicking of the edit object, and this one is deleted. And here we can see of the find object button. We find out what the map correction were made. This here in this position have a symbol map correction and activating to here. Another section is display options. We can adjust the display properties of the added information. Here we can write what information will be visible or not. If we added a boy, symbol, line, text, depth, or shape, if we wanted to see not visible, now this is visible, and as if we click again and not activated of the visible object. Or deleted, activated and not activated. Overlay, the Admiralty information overlay, and this section. Previously, notice to mariners correction were manually processed on the chart paper. Now the correction published by the countries by the IO are automatically processed into the system. At the Find button, when we start to search for a map correction method, we can find it here. Normally we are selecting in this menu of the IO correction. After that we are clicking of the Find, and it show us the here of the TP notice information and which energy chart is affected from this information. It show to in the section. The sensors we are using here, DGPS sensor, DR and EP can be adjusted as primary or secondary sensor. Like we are selecting of the DR primary sensor or estimated position secondary sensor, we can set from here. Or for the DGPS, it shows the information it receives from DGPS here. Primary DGPS information are show us our position. In case of malfunction, position estimation can be made with data reckoning. We are selecting of the data for the data reckoning, and we can set by cursor from here. Estimated. On the other hand, in case of the malfunction, estimated position can also be determined with previously fixed position. Like radar position, we can fix our estimated position. For this, we are selecting from here. Again, primary or secondary. On the other hand, heading, this information is normally obtained automatically, but we can also enter it manually if we want. We can say automatically activated, or manually we can add to from it. At the speed log value can be entered manually, and set drift value can also be entered. Normally this one should be activated, and we can add the set and drift value for our navigational voyage. Echo sounder, for a safe navigation, the values taken from the echo sounder can be entered here and also used in the same way. And we are selecting echo sounder 1 or echo sounder 2. We are entering of the here ship's draft, and it automatically of the calculations.
Monitoring. In the monitoring, we can see route monitoring, safety alerts, and navigation alerts. In the route monitoring, headline is the direction the ship is going at that moment. Course over ground vector and heading vector. In the course over ground vector, the current direction of the ship is shown by including the current, tide, etc. But in the heading vector, these parameters are not included. So we can use heading like speed through water. We use to avoid collision on radar, even if it's not in the Ecdis. Also, we can adjust ship by contour from here, wind vector, and when we select the ship by contour, we can see our design ship, length, shape. From here, we can select which option we want to monitor or not. And also here, from here we can decide at which interval our path track will be plotted on Ecdis. Safety alerts. At the safety alerts, the most important things, safety parameters for our passage plan. Because the safety contour is highlighted on Ecdis task screen with a bold line, safety contour parameter cannot be larger than safety depth parameter. If, however, the operator sets a larger value, the same value is automatically assigned the safety depth parameter. As you see on the screen, we can set these values, safety contour and safety depth, according to our navigational manual. We can adjust deepest navigational draft minus and other factors. Just to give an example, we can say isolated dangers. If the isolated danger has a safe passing depth less than safety contour, it will be considered not safe to pass over and the top warning symbols will be in use. If the safe passing depth is more than safety contour, the isolated danger becomes insignificant. Source of safety parameters. From here we can decide from route or fixed. If we select from route, safety depth and safety contour will not change. They will be blocked. But if we choose the fixed, we can adjust all safety parameters. Because when we choose from route, it will directly take from passage plan. When it comes to safety frame, for ahead we can say it's for the input of advanced time for alert generation and its source is speed over ground. For port and starboard we can say the width of the corridor to left or right of the ship. Area alerts, for better planning we can open all of them, but we can choose just the required ones for reduced distraction and overloaded off screen from here. Navigation alerts. It depends on the navigational status of the vessel which alarms make sense in being activated. If the wrong settings are made, alarms may not be considered or may be acknowledged without paying attention to it. We can see from their anchor watch settings when we click the down and by cursor we can see the anchors. Before passage planning, we should adjust default settings, safety parameters from configuration, because it directly affects our passage planning settings. And then when we came to route planning, we can adjust the new route. Firstly, we should press the new button for generation of a new route, and after that we will see graphic cursor will appear on the chart panel, whereas the right button part of screen will display the place first point information window. We can set the cursor in the start point coordinates by moving the trackball using the data in the place first point window, and when we finished we should press the left button. After the setting of the last point of the planned route, double click the right button. The cursor will exit from the route planning and editing mode will assume the form of the free cursor. From here, when we double click, we can change the name of the waypoint. Also, we can adjust the cross-track error values for confined water at least 0.1 nautical mile wherever possible and practicable, and for coastal water minimum 1 nautical mile, for open water minimum 4 nautical mile as per our navigational manual. For turn radius, we should check below over postal from bridge, and sailing distance are two types. When we double click from here, we can change ramp line or grid circle. The ramp line for shorter distance and grid circle is for longer distances. This panel schedule, we can see ETA, time zone, ETD, etc. Also there is a extra data panel. In this here we can see remarks, draft, UKC, safety contour and safety depth. Safety depth and safety contour from the default settings in the configuration panel. Remarks also, when we double click, we can add some. Also here there is some options, for example waypoint names, turns, etc. We can select which option we want to monitor or not. For example, changing coordinates of an existing waypoint. Firstly, we should press the left button the marker will acquire the waypoint and change its own form. And we can move the acquire waypoint to the we should press left button. The waypoint will be set in the new coordinates. We can press the left button. If we want to setting a new waypoint, we set the marker will acquire the new waypoint and change its own form. We can move the acquired waypoint to necessary place. As the waypoint coordinates change, the adjacent route legs will change, and then we press the left button. The new waypoint will be set in the specified coordinates. If we want to delete a waypoint, position of the acquisition marker on the waypoint to be deleted, we should press the left button. The marker will acquire the waypoint and change its own. And when we click the right button, the point will be deleted. The adjacent route legs will be combined to form, and we should press the right button to exit from the editing mode. The marker will assume the form of the free cursor. If we want to shifting a route, we can come here, edit pose option. When we click the shift, there is a orange square on the screen. When we choose the waypoint, change position, and we will see there is a EBL and VRM. And when we click, the waypoints are shifted. That is also on the passage planning. There is an important point: SAR routes. First of all, we should claim the tasks. When we claim the tasks, as you see on the screen, there is SAR, tides and ports. On the SAR section, there is a SAR route generation. We can select the routes from here. For example, expanded square, parallel tracks, left track search, sector search, track line search, grabbing line search. When we click these routes on the screen, we will see the which route is activated. If there is a SAR operation, we can adjust from this section. After that, we can adjust the tides and ports. In this section, we can see the port name and informations about it. We can select to put the port name from here by name or from the table. This port name is Ceuta, so we can see on the screen Ceuta's informations and table which hours we can navigate or not. On the diagram, now you can see the red one. The red colors means we cannot navigate in this area because we didn't adjust the minimum chart depth draft on UKC. And for example, the UKC is 2.5 and our minimum chart depth is 14 meters. Now this is blue, the color is blue. Blue color means we can navigate in this area, but still we didn't adjust our draft. When we adjust the draft, we can see we navigate or not. Now in here, after we calculate the total other factors, we can write here our deepest navigational draft. After adjustment of the UKC, we can check from table which hours is safe for our navigation. So we can say deepest navigational draft is important for navigation. Also in the ports, we can select the ports in this task. Targets panel. In this section, we can sort the targets as we want by selecting them from here. And according to company policy, we can change the CPA and TCPA values here. For example, in our navigation manual, in the coastal waters, CPA is 1 nautical miles, the TCPA is 15 minutes. And we can also adjust how far away we can see the ships that has AIS from here. But first we should open AIS. And then from the left hand column we can also specify how to sort by what. For example, CPA, TCPA, name, etc. On the right column we can see AIS messages. If there is any AIS messages, we can see in this section. Environment data, tides, tidal currents. We can see on the chart tides and tidal currents. If we click the animate and when we enter the date, ship's time, we can see where is the tidal currents. Manually fix position. We use this part to check position on Ecdis with using radar. Firstly, we can take EBL and VRM from radar screen. But if we are using overlay option, we can also take EBL and VRM on Ecdis. After that, we enter these values to Ecdis here. If we take bearing and distance, we should enter the bearing distance, this part. After that, we click apply, and then after adjust the values, we need to push move and reference to shift our LOP on reference point. Finally, we can accept the position. For example, the bearing is 300 and range 0.5 nautical miles. So now we can adjust these bearings and distance here. The bearing 300 degrees and the distance 0.57 nautical miles. And if you want, we can give a name and click apply. If you click move and reference, you will see we can move this LOP position when the vessel is moving. Also we can move. So as we said, we can shift our LOP on the reference point, so we can accept the position. Finally, when we came to Navigator section, during navigation we can see some parameters here. We can use this section and parallel index line. Actually, using parallel index line is better for radar screen, so please do not use parallel index line on Ecdis.
Position instruments. In this part, estimated information is given about how the bow and stern of ship is turned and about its estimated rate of turn information. In CHL part, an estimated scenario can be created with the estimated commands we will give to the ship. And this predictor part, it's related with CHL part. Radar settings. We can do some settings, radar overlay of the ship. We can arrange the range. We can active or deactive the rings. We can arrange the brightness gain or some arrangements. Route data. Route data shows the data on our current route. It shows which route is active and information about the route. For example, route's name and cross track distance, ETA to other waypoints. In schedule part, it displays information about the waypoint we selected. And in addition, the quick calculation feature can be calculated based on ship speed or estimated speed. Quick calculations here. In RDV part, Ecdis has a piloting feature, as we know. Piloted ships can be seen in this menu. Target 1, target 2. We can see some information about them. Sensor data status. It shows the reliability of the ship's position. For example, its position, and how many satellites it receives information from, and some information here. Special purpose objects. In this section we can add items according to added object data. This item work simultaneously. For example, static item, and we can add item to the position, and we can do some settings from here. Sun and moon. This shows the information of the sunrise and sunset times of the sun and the moon in the selected region and date. We can set point from here, for example here, and click calculate. We can select data from here and time from here, and it shows the information. System information. This part gives us the information about our drift and current, or we can see true wind, relative wind, and of course tide informations. Trial TGT Simulator. We can do in this section trial maneuvering according to our estimated information. When we activate the trial mode, we can see T symbol in Ecdis. We can see here, and if we don't want to play this simulation, we can pause it. Targets. We can make adjustments to the alarms of the targets we plot in Ecdis. And in this AIS part, we can also make adjustments for the AIS targets. Track control panel. It shows the information about current route as like route data. And also we can adjust EBL and VRM data. The variable range marker and electronic bearing line measure the distance and bearing from our ship to a target object. We can see here EBL line. If we press this button, the line will show the selected bearing. Here shows, and VRM also shows if we press the button. We can adjust the values. For example, 5 miles. Here we can see the variable range marker. Of course, we can arrange the electronic bearing line value. We can see. Thank you for your attention. Have a good day, have a good watch.